Hey guys, welcome to our second video note of second semester. I know we don't do a lot of videos now a day, but the reason we have video notes today is because we didn't lecture in class. So you don't have any book homework, therefore you have video homework. Alright, so in class we finished defining all of our vocab and theorems. So today we will start with example 1. Excuse me. And we are going to see how far we can finish, okay? Alright, now before I start lecturing, I want to bring this up to you guys. I found this reading, and it's really interesting. It says how to retain 90% of everything you learn, okay? And you know what? You know what the top of this chart is? How to retain 90% of everything you learn is this. 90% of what they learn, okay? 9% of what you guys learn when you teach someone else immediately, okay? So with this video note, if all you do is you listen to this video notes, okay, then you just learn 20% and that's it, okay? Now, if you watch this video note and you read your book, then you go, okay, so you listen to me talk, you see it, okay? 5% of what you learn, only 5, when you, or they, in this case students, have learned from a lecture. So me lecturing to you, and all you do is sit there, you just soaked up 5%, okay? Now, 20% of what you learn from an audio visual. So that means you watch and listen. Okay, you watch and listen. So visual and audio. Okay, if you just listen alone at my lecture, you're not going to learn 20%. Okay, so keep that in mind. So right now, if you're not listening, you need to listen, because even if you're listening and watching, you're only soaking up 20%. Okay? Now 75% is when you go and you practice. When you go and you do your homework. Practice means homework. Okay? Then 30% is when 30% what you soaked in, okay, when you see me do it. So that means when you watch me. Watch me practice. Okay? Now, but remember, you need to listen and you need to watch at the same time. Alright? But the key thing right here, guys, is really you need to practice your homework. And even better, aim for 90%. Go teach someone else. Go teach someone else. When you have an opportunity during tutorial or during class, explain it to somebody. Alright? That's really interesting. Alright, so today we are starting with example 1. Convert each angle in degrees, okay, to radians. Oops, whoa, you can't see that. Oop, there you go. Convert each angle in degrees to radians. Okay, and I don't want to use a calculator because it says express your answer as a multiple of pi. So 30 degrees. Okay, keep in mind your answer is going to be in radians. So for 30 degrees, and as you remember, let me tell you, I want to go from degrees to radians. Okay, so currently we have 30 degrees, and I would like for us to get rid of the degree symbol. So 30 degrees, we are going to go in, and we can make 30 into a fraction of 1. Okay. So 30 degrees over 1 times, because I am trying to get rid of the degrees, okay, 1 degree equal to pi over 180 radians. So I can go in and multiply by 1, okay, or aka 1 radian, it's 180 to pi. So I want to go from degree to radian, so this is what I need to multiply. So if I go in and multiply by 1 degree, okay, so I'm going to go and multiply by 1 degree. I'm not going to change anything. See that right there? Okay. So because 1 times anything is itself. But 1 degree is equivalent to pi radians over 180. So this is, I can go in and multiply by pi, divided by 180. Oops, not 800, 180. Let me get it right out. Excuse me. So you go in and you multiply by pi over 180. Okay. Pi 180. Okay. So this is going to help me, because this is really, in reality, this is pi radians over 180 degrees, right? Pi radians half a revolution. 180 degrees is also half a revolution. So they equal to 1. 1 times anything, it's still itself. So I'm really not changing my angle. I'm just trying to make it into a different unit of measurement. So 30 degrees into 180 degrees, that will leave me with, reduce that down to, this is 1, and this is now 6. Okay? Because the 0 and 0 cancel. The degree symbol would cancel. And sorry, this is pi radians. Okay. Then 18 divided by 3. 18 going to 3 is 6. So on the top, 1 times pi is pi. Okay. 1 times 6 on the bottom is 6. And pi over 6 radian. Because pi is about 3.14. Okay. So if it's 3.14 divided by 6, it's not quite a full radian yet. It's a little bit more than half. Okay. So similarly, we are going to convert 120 degrees into radians, okay? And leave it as multiples of pi. That means no calculator. We are going to take 120 degrees, okay? We are going to make it into a fraction. So put over 1. So we're going to multiply, okay, pi radians, so pi rad, over 180 degrees. So in reality, we can go and cancel out the degree symbols and the zeros. Okay? So this is pi over 18. I'm saying not pi, 12 over 18. I can also go and reduce it again. I'm going to divide this by 6. So 12 divided by 6 is 2. Okay? 18 divided by 6 is 3. So on the top, I have 2 pi rad over 3. So I have 2 pi rad over 3. Or I can write 2 over 3 pi. And because we need to write radians, so this is radians. Okay? And over here, we need to write radians. Alright, so you can either write the pi on the top or the pi on the side. Just never, ever, ever on the bottom. Okay, next one. Negative 60. Convert it into radians. All we do is we are going to make into a fraction and multiply this to pi divided by 180. Okay. So again, we can think of this as 180 degrees and think of this as pi rad. So if that's the case, okay, 0 and the bubble will cancel out with this 0 and the bubble. They're both reducible by 6. Okay. So 6 divided by 6 is 1, but this is now really negative 1. 18 divided by 6 is 3. So on the top, negative 1 times pi is negative pi. On the bottom, we have 3. And then this is going to be radians. Okay. So pi is 3.14. 3.14 divided by 3 is slightly larger than 1. So that's why it's plural. Alright. So these last two, I would like for you to accomplish on your own, please. On your own. Okay. How about OYO? OYO. It's on your own. Oh, yo. On your own. So when I stamp your notes the next time, I would like for you to have these two already done with the answers completely boxed up. So just hit pause. Try it now before you forget. Okay. Keep in mind. Okay, going back to this, 75% is what you retain when you practice. Okay, so go ahead and practice. Okay, so now that you have done those two on your own, let's go to example 2. Convert each angle in radians to degrees. So currently all of this right here is in radians, and I would like to go from radians to degrees. So you can go, hey, pi over 3 radians. Okay. So we can you can make this into a fraction, and radians, you can write it on the top like that. Okay. Now, times. So let me bring back that chart. Excuse me. If I take the radian and I go multiply by another radian, so pi radians multiplied by 1 radian, I'm not going to change anything. So, excuse me, multiply by 1 radian is the same thing as multiplying 180 divided by pi degrees. So what we're going to do is, we're going to multiply, according to this, 1 radian is equivalent to 180 divided by pi. So, we can multiply pi radian to 180 degrees here. Okay. So when you think of this, you can extend this a little bit. Okay. This is pi over 3 radian. Radian can be on the side or radian can be on the top. So pi and pi, those are reduced. Radians and radians, those units are also reduced. So now the only symbol we have left is the degree. So 180 degrees divided by 3 is simply 60 degrees. Okay. Alright, next. Negative pi over 2 radians. I'm going to do exactly the same thing. I'm going to write pi radian divided by 2 times. Okay. Anytime you're converting radian to degrees, you just have to put the pi on the bottom. Anytime you're converting degrees to radians, you put pi on the top. Because if you think about it, the degree symbols have to be opposite of each other for them to cancel. So I need to cancel out my radians. That means pi radians is going to be on the bottom. And pi radians is equivalent to 180 degrees. Okay. So let's get pi and pi will cancel. Radian and radian unit will be canceling. So now I have a negative 180. So negative 180 bubbles divided by 2. Need to reduce that down to a negative 90 degrees. Okay. Is that easy enough? Okay, I would like for you to go and accomplish these two on your own as well. So let's call it, oh yo, on your own, smiley face. Oh yo, on your own, smiley face. Okay, so go ahead and hit pause, please. Don't unpause until you're completely done with those two, in addition to the first two on your own. If you don't do it now, you will forget. So you might as well get it done. Okay. Let's go to example 3. Example 3 says, first, draw each angle in standard position. Okay, keep in mind that you have already had all of these vocab defined. A, state what quadrant is it is in, or if it's a quadrant angle. B, find its reference angle. And C, find its one positive and one negative coterminal angle. So there's a lot of things going on here, and I wish I would have spaced that out a little bit further out. But, oh well, we're going to make it work. Let's draw half. Okay, whoop, here we go. Let's see what's behind this page. Okay, so just more of the same kind of problems. So moving on up. Okay, so first thing it says, go and draw each angle in standard position. So we're going to draw standard position, meaning that we're going to start with the initial side. Oops, you can't see that. There you go. The initial side is going to be right there. Okay. The terminal side, because it's 45, positive 45 degrees. This is 90 degrees, so positive 45 is right smack in the center. Anytime that you're drawing, so that's your terminal side, you need this arrow. Okay, this arrow is telling me that you're going to go a positive angle. So all you do is label this 45 degrees. Okay, so the drawing piece is done. Okay, part A, state what quadrant it is in. So what quadrant is 45 degrees in? It is quadrant number 1. Okay. B, find its reference angle. So B, reference angle. Reference angle, if you remember the definition, and we said in class that this is one of the most important ones to know, is an angle that is less than or equal to 90 degrees. Okay? Because this is already less than 90 degrees and it's already positive, the reference angle is itself. And because we started with degrees, every answer has to be the same unit of measurement. C, find is one positive, one negative coterminal. So C said positive, okay, and negative. We're going to need 2 answers. Okay. So a co-angle, meaning that I can't have the same one. Okay, so what that means is, I'm going to get a pencil. Positive angle, meaning that I would need to start at the same place, because I can't end at the same spot because that's 45 degrees. Because coterminal angles mean 2 different angles. Okay, so that means I need to go a full revolution. Then I can come back to that. So positive coterminal angle is going to be, hey, a full revolution is 360 degrees. Okay, plus this angle right here, this is your reference angle, so plus your reference angle of 45 degrees. So my positive angle is going to be 360 plus 40, that's going to be 400, and then we have 5 degrees over, so 405. That's my one positive coterminal angle. Now technically you can have as many revolutions as you want. So technically I could go another revolution, so that's 720, and so on and so on. But I'm always going to ask you for a coterminal that's the smallest positive, okay? And then in this case, in absolute value, the smallest negative angle. Because if I let you go, you can technically all have different positive angles and all different negative angles, okay? Now how about negative angles? Negative angles meaning that you will need to start here, and you're going to have to go clockwise. So if I were to go clockwise, okay, this is where I would end up, because coterminal means I would end at the same exact place. So how does that work? Well, how big is this angle, this red angle, right? So all you do is you take 360, because it's almost a full revolution, okay? And then all I do is subtract the reference angle, which is 45 degrees. So if you look at it, 360 minus 45. So you can do, hey, you know what? You can do what? 360 minus 40. So that's really what? 320. But then I have 5 degrees over, so that's really 315. But because it's negative, remember we went this direction. Whoop. So it's negative 315 degrees. Okay. So that's how you kind of think of it. Now, could I have done a full negative revolution, so negative 360, and then go backwards and add 45 degrees? Of course, okay? Either way, you're still going to end up with a negative 315 degrees. So if you want to go, hey, I'm going to full circle, okay, and then backtrack, so I can end here, then that's what you would do here. So let's see, we state the quadrant. We found the reference angle. We found one positive and one negative coterminal. We drew it in standard position. Okay. Let's do one more. Actually, you know what? This is where we're going to leave off because it's about 20 minutes. So before I leave you, let's give you a joke. What's the tallest building in the world? What's the tallest building in the world? The library, because it has the most stories. You get it? Okay. You know I love you. Until next time. Adios.